with Engineer Trudy Morgan. We have our layman's perspective, those of us who are not engineers, as to why these buildings collapse. If it's not a whole building, sometimes it's a fence. We've had stories of it's poor construction, or no, it's substandard building materials. That led to another conversation on its own. But as an engineer, what's the explanation for what we've seen?
Well, I mean, it's interesting to say what's the explanation, because there is no one thing. We live in a system, and in various systems, various ecosystems, there are lots of processes and procedures that make up that system. When you look at building, in order to create a building, there is a process that we need to go through. First of all, to create a building, we need to identify the land. So there's land use validation that needs to go through, i.e. we need to understand that this plot of land is available and suitable for the type of building that we want to create. Then we need to go through the process of designing the building before we construct it, and then we utilize it. And along that value chain, there are lots of other considerations that we need to think about, apply, in order for that building to remain standing 5, 6, 20, 50 years on. So if we look at the first one, let's say land use validation, what does that mean? It means that if you have an area, a city, a community, in order for you to put a structure there, it must be planned. It must be properly planned, because buildings don't operate in isolation. It's 2024. That means that if we have a building, we need to connect water to it. We need to connect power to it. We will have neighbors. We live in Sierra Leone. It is the rainy season. We must have drainage. We have neighbors. We can't build too high because we might block their sunlight and keep them in the dark. There are lots of considerations that must happen during the land validation process. And that requires things called structural plans, area plans to be drawn up. One of the challenges we have across the whole country is this issue of zoning, but I'm going to park that for the time being. Let's move on to, let's say we now have a piece of land that we can say the person can build. We need to ensure that they don't build in a water course, and we need to ensure that they build in a manner which, of course, doesn't affect their neighbors. The next thing we need to do is to design the building. When it comes to designing the building, we as engineers have always been very careful to explain that the engineering, that the building process is not one where you just come, I get a drawing and I build it. That's it. The first thing we need to understand is right across this beautiful country of ours, we have different soil conditions. The different soil conditions mean that when we put things, structures upon it, it reacts differently. If I put a building on sand, the reaction will be very different to if I put a building on clay. So that means that when it comes to designing the building, I must understand the soil conditions. So the first person, after the architect has drawn your drawing for you, the first person that you need to talk to is your geotechnical engineer. And they do what is called a geotechnical investigation, i.e. they dig around the ground that you want to build on and confirm that to you that the land that you're building on has different types of soil, different strata. And that helps you do the most fundamental of things. It helps you create a foundation that will situate your building. So a lot of times we do a lot of what we call cut and paste. I like this one in building, can't build that for me. Not understanding that he may have built his building on solid rock. Your land is clay, therefore the reaction is different. Your land is sand, therefore the reaction is different. The foundations that we use generally in Sierra Leone are just generally rough foundations. So we have a way of building it. You know, we use the boulder and we put the soil, we compact it. Not bad. Not bad if you're doing 1 or 2 stories. But when you start to build multi-stories, you need to do a proper investigation. And we don't normally do that. And what happens is you now put buildings in areas where, for example, we've seen a lot of people put on sand. They've put flat raft foundations. Well, think about it. What is sand? It's very granular. So you need to have something whereby it's able to go through pretty deep. It's also able to have the friction that it needs to hold the building. And those are called pile foundations. So there's a lot of things that even go before we even go onto the structure. Having built your foundation, we need to think about the actual structures. And forgive me if I sound as though I'm teaching a class, but I want us to understand something. When we're building, we build ground up. We have to understand what we're building on. We build top down. We have to understand the loads that are going to go onto the foundation, because the foundation is meant to carry the load and transfer it to the ground, to the soil. If it doesn't do that, then we can talk about that in a little bit. So one of the things that you see them teach you when they go to the university is they'll say, in Sierra Leone, we have this amount of wind. And that wind is actually calculated onto the roof. That wind, that roof loading has wind loading onto it. So when they design your roof must also bear the wind load, because it has a mass, it has weight that goes onto it. You then have the process of from the roof, it goes onto the beams, and then they go onto the columns, those columns. Now, interesting thing here. When loads are meant to be transferred, when you're designing a building, you're meant to transfer the load from the top all the way to the bottom. If you have a column that's doing that, and the load is supposed to come like this, all of a sudden it doesn't have anywhere to go. So it puts an disproportionate amount of load on the wrong part of the column, and then you start to have an issue. If you have a column that is too narrow and too slight, and you have heavy load on it, it starts to crush it. So designing, it's important. I'm almost done this part. And then you have the beams that transfer onto, or that sit and transfer the loads from the slabs onto the columns, and then they come all the way down. Now, a lot of times people just say, they float. Now that means that they're pouring a slab. But if you're floating for a house where you have a mother, father, 5 kids, versus an office building where you have people in and out walking all day, versus a nightclub where you have people dancing and jumping, versus a gym where you have people using loads and dropping loads. The loading on the slab is different. Am I right? No. Yes, I am right. So because you know that this is what the building is used for, you then design the slab to carry that load. It's called the dead load, the weight of the slab. Then it's called the live load, what the people do on it, the dynamics that go on it. And then that load is then transferred, not to the walls, to the columns, and then to the foundation. And a lot of times, what happens is we take cut and paste, it don't do it for so, it do it for so, and then you have a situation where we're designing buildings and that are meant to be, I don't know, 2-3 stories, taking that same level all the way up to 11 stories. And then we have collapses and we wonder why. I'm going to jump very quickly, very briefly, onto the issue of construction. Let me just finish, because it is a process. I said you've got to validate that the land is correct. It can be used. It's not you're not in a water course. You've got to design it properly. You have to use the correct people, because generally what you find out is that you have somebody say, oh, I'm not a contractor, I can't design. Takes your architectural plan and constructs it. But the real issue, all of these young people go to university, myself included way back when, is so that we understand the principles of when we're designing structures, be they houses, be they roads, whatever. We know the correct loads that need to go on it, the correct drainages that need to be applied based on the size, the correct heights of your slab, the correct widths of your column, so that the loads can be transferred properly. If those loads are not transferred properly and you have misalignment, you will get a collapse. In engineering, at Phebean College, they do civil, mechanical, electrical, and mining. Let's take the building. You will need the foundation engineer, who probably has a basis in civil engineer, to draw your foundations. Then you will need a structural engineer taken from the architect to make sure that your structure is structurally sound. Having done that, you then invite the mechanical and the electrical engineers in. Let me explain what happened to my cousin. Well, my god brother. He's not a cousin. He's just Salon Fambo, god brother. So he, unfortunately, had somebody come and do rewiring in his house in Tengbe Town. They went to work. He got called to come back home. His 3-story house had burnt down. Do you know what they used? Rather than use proper electrical cables, they used the thinnest of the cables to rewire the house. So the lights went off. There was a surge. It caught fire on one of the sockets. There was nobody in the house. They had locked it. The kids had gone to school. They had gone to work. That fire then spread because it didn't happen in one place. It happened in several places. And the whole house burnt down because it wasn't engineered for the usage. In this building, sorry, okay.
This brings us to 2 disasters in one, because fire disasters have also been a concern in Sierra Leone. We've heard, you know, a lot of buildings caught up in flames. We'll come right back to you in a moment. This brings us to Mohamed. Engineer just made us understand that what we had thought earlier of buildings to be so easy as finding one contractor, this is what I want, let's put it together. It's not as easy as should be or as we do it. It's more complex. But the problem is, lack of knowledge leads many people, both educated and uneducated, to make that error of just hiring any contractor recommended just because they've put a building together before or have worked with someone, not properly looking into the qualification. And it also seems that the structures are failing. Structures of who should be asking for building permits, asking for what document, which would then lead to the knowledge of to say, you're not using the right contractor. The system is failing the people, so it seems.
Well, I cannot entirely agree that the system is failing the people, because the NDMA, of course, you could recall, it was established, you know, in 2020. And initially, when we started working, you know, it was a whole, the issue of disaster is a whole new phenomenon in Sierra Leone. So what we did, you know, in because it was in November 2020, what we did in 2021 and 2022 was to actually develop a hazard calendar to look at the various categories of hazards that we were exposed to. And initially, by then, we did not capture the issue of building and fence collapse because it was not prevalent. So it was only, you know, as early as 2023 that we started recording, you know, building and fence collapses. So that is the reason why we have actually taken it very seriously. At the NDMA, we have categorized it now as a hazard because it, you know, it is prevalent and is killing people, which is very, very sad for us. So the NDMA also collaborates with other, you know, professional bodies, you know, who have the expertise to provide some technical, you know, support to us in ensuring that we are able to tackle this particular issue. That is why, of course, Trudy is here. We invited her during our interpillar coordination meeting, you know, when we discussed this particular challenge and the hazard. And of course, she made a very good presentation. And it was on the basis of that, you know, we want to intensify the awareness. We want to encourage citizens, because most times I will tell you, it is not that we have not been doing enough sensitization on this building collapse and also do fire prevention campaigns or encouraging, you know, residents to be using qualified electricians to do their electrical installations or get quality materials. You know, we have been doing that. It is just that the attitude of Sierra Leoneans, I want to put it to you, that it is a bit, you know, they are a bit stubborn. I want to put it to you. We have done a lot of fire prevention campaigns across the country. In fact, in 2022, 78% of the fire incidents that were recorded were as a result of electrical malfunctioning. You can go to Fire Force Of course, we did that together. And
but
we
there's
arrived
not
at that
been
conclusion.
much education on.
We have done a lot of fire.
On the how you select a contractor
So,
for your construction.
So that is why it is as recently that we just categorize this now as a hazard. We are taking it now as very, very serious. So that is why we've started now this campaign to encourage the public, especially those that want to do their construction, to actually hire the services of qualified engineers so that they can provide the necessary, advice to these, people so that we avoid these tragedies. Most times, like she rightly pointed out, is that people, can't go build for me, the same house will build for me, forgetting to realize that probably the topography is not the same, the soil is not the same, and you cannot have 5-story building at this particular location and all of that. So it is, the people, what
but
is
this
important.
Is why I say, Mohamed,
this
is why I say the system is failing the people, because the system as put, there are institutions you're supposed to present your structural plan to, and if you have the wrong people doing the right work, somebody somewhere, one of those institutions, should be able to pick it up and say something is wrong. So, the location of this proposed property and the plan we've seen, there's a mismatch somewhere, so and it's a disaster in making.
There are two things to that. Understand? One, in the absence of the public adhering to government directives, that is a challenge. It's going to be a challenge. Additionally, of course, the issue of building does not fall entirely within the remit of the NDMA. We have the Ministry of Lands who are giving building permits, and we have the Ministry of Environment, we have the Ministry of Works, to actually look at the structural design, the integrity of the structure and all of that. So we have been collaborating very well. We have been collaborating. The Ministry of Land, I understand that they are trying to develop, systems in place to ensure that they, provide building codes, for example, for anybody that wants to do any construction before you can go ahead. And all of those systems, I understand, that they're actually thinking about.
Yeah, they've been thinking about it forever. But now that we've come to a point where disasters are occurring,
so that is why we are here.
Structures,
that is why we are here.
How are you fast-tracking that process?
No, that is why we are here.
And monitoring.
Yeah, that is why we are here. First of all, to encourage the people. Secondly, to explain to them the dangers of using unqualified professionals, people, to do either their electrical installation or their construction. So if we have these people adhering, most times you find out these people, if they hire the service of qualified engineers, if they charge them, they want to pay cheaper, and if of course there is no agreement, in terms of the money that they should pay to these qualified engineering companies, they will tend to go and use other people that will accept less and endanger their lives. That is the very reason why we are here. We are encouraging the public. We know it's a challenge, and we have categorized it as a hazard. We are encouraging the public, please, if you want to develop a 5-story building, hire the service, do due diligence. Let there be visibility studies. Let there be professionals that you ask to verify, to do an assessment. Of course, and for the entire structure, whether it is suitable for construction in that particular location, whether it is indeed feasible that a 5-story building would be constructed at that particular location, and all of those things. Most times they don't do that. And even where you go and demolish, and then 6 months later you go there, you see they will start to construct at night. So that is why we are appealing to the public. Yes, the issue of enforcement is key, and we have been doing that as well. But in the absence of people adhering to most of our directives, I think it will always be a challenge. It will always be a challenge. So that is why we are asking. Behavioral change is very important. The reason is, if there is any disaster, the government, NDMA will come in and provide some relief support. But that will only happen if there is no loss of life. If there is a loss of life, the government will not be able to replace it. So that is why we are actually admonishing the public for them to take action. Say, for example, you cannot be in a house 10 years without doing your electrical, you check your electrical installation. Some people, since they constructed their houses, they will never done it. We've done a lot of sensitization on that. That after every 5 years, please check your electrical, your wirings and all of that. Ensure that you buy quality materials. Because most times, like Trudy said, you have people do, for electrical fires, for example, they will connect illegally. They will have 10 or 15 houses connected to 1 meter, for example, or rooms. They have high voltage appliances you have like a small circuit breaker, connect all of those appliances to that one breaker, and the power of those appliances outweighs that breaker, definitely will catch fire. And most times they are not even around. So if we have people adhering to these standards, I believe greatly will minimize the occurrence of these incidents.
Okay,